Intrepid comes as a Python library. In order to show you how to install it on a fresh machine, I will be using the Docker framework. So I'm using Mac OS, and this is a Visual Studio Code page, which can be divided into a terminal and into a notebook where you can write code. So if you are on macOS like me, you will need Docker to be installed on your machine. Otherwise, it will work also on Windows and Linux with a slightly different experience. So first of all, I will have to download the Python 3.8 image. So this will create a machine which is completely fresh, where you have installed a Python 3.8 version. It was fast for me because I had this image already in place. If you do it the first time, it will take some time to download it. Now, if I run the Python interpreter and I try to import Intrepid with the Y, it will say that the module cannot be found. So I'm getting out now, and I type the following command to install it. So Intrepid exists on the PyP project online, and when you type this command, it will automatically download Intrepid and all its dependencies and install them on your machine. It is provided for Linux, for OS X, and for Windows as well. Just a second. Okay, so now if I run again the interpreter and I type import Intrepid again, then the import doesn't fail, and I can effectively start using Intrepid. We see now how we could create circuits with Intrepid. On the right hand side you see a circuit, and on the left hand side we will create it with the Intrepid APIs. So first of all, we need to import Intrepid context. So as you see, Visual Studio Code is clever enough to do the auto-completion for the library. And now we need to create a context object. Once you've done it, we can use it to create inputs, gates, and latches. So first of all, I need to create a Boolean type, and then I create the first input, giving it a name, a unique name, and a type. Similarly, I can create the second input and a Boolean gate that ties the two. As for the latch, I will have to initialize it in 2 steps, because you might want to create loops involving a latch. Sequential loops are allowed in a circuit, whereas combinational are not. So in order to create a latch, I will type the following. Again, I can give it a name and a type. And then I have to initialize it separately. So as latch, we put latch1. As the initial value, we set it to false. And as the next state, we set this AND1. So right now, the circuit on the right is stored in memory inside the Intrepid context. Let's see how we can simulate the already created circuit. In order to simulate a circuit, we need to create a so-called trace. A trace is a set of assignments that can be given to the inputs at any time frame. So we need to specify some of these values. For instance, I will tell that at depth 0 the value for input 1 is true, that the value for input 2 is true as well, and I will also set values for depth 1 like this. So since the behavior of the circuit is completely specified by setting the values for the inputs, we can now perform a simulation where we can watch the values for AND1 and latch 1. So in order to do that, we need to create a simulator. And we need to tell the simulator the things that we would like to watch. So the nets in the circuit that we would like to watch. Inputs are always watched, and so if we want to see the values for AND1 and latch 1, we have to explicitly tell the simulator to watch for them. And then we can run the simulation. We can simulate the trace for depth 1, so it will run depth 0 and depth 1. In order to see the result, basically the simulator will update the trace that we have created here with the values for AND1 and latch for each timestamp. So we can then retrieve the trace as a pandas data frame if we give a mapping between the net and their name, which is automatically filled out by the context object. And by running the simulation, we'll see that we get exactly the expected value. So the latch is initially 0 or false, and because the inputs are both true, and so the AND gate is also true, and the next value it will get value true. This symbolic name here is for the AND gate, which I left the tool to create, but if I specify it explicitly, I will get the proper value for that as well. I'm taking now a slightly more complex example. This can be retrieved from the EDA library of that comes with Intrepid. So it's basically a clock signal, which you can see here on the right. So it goes up and down at every timestamp. And I set up the simulation here in order to see how the clock behaves in 10 timestamps. And if I tell the UPython framework to produce the result, this is the outcome. So as you can see, we can have the simulation for 10 timestamps. Where you see the question mark, it's because the input is not relevant. The input is behind a multiplexer, and the multiplexer is active only at the first timestamp, and then it becomes irrelevant, this branch. So it will be just the latch toggling at every timestamp, as you can see also from the plot of the clock and the plot for the input, where -1 value has been assigned to the question mark. Let's go back now to our previous example and finally do some model checking. In order to do model checking, we need to create a solving engine. Intrepid supports a bounded model checking engine, an optimizing bounded model checking engine, meaning that you can give multiple targets and he will try to find a trace that satisfies the majority of them. And it also has a backward reachability engine, which is a sort of IC3 kind of backward reachability. So let's start with the BMC first, and we need to specify which target we would like to solve. So the target is basically a bad state that we do not want to reach. It's otherwise said a negation of a safety property. And similarly, as for the simulation, we might want to watch latch 1 values so that they will show up in the trace. And now we can set the current depth and ask the engine to reach the targets. So let's also print out the result. So if we run it like this, we will see that the answer from the engine is unknown, because at that 0, the output of the latch will come out and the bounded model checker will not be able to find the counterexample. He is not able to prove the property as well, so he will just say that at this point the answer is unknown. Actually, the BNC can be also enriched with the inductive checks of temporal induction, but in this example I will not show. So we need to go deeper to find the counterexample. So I will now set the depth to 1 and run again the tool, and now it says that it is reachable. So we can get a trace out of the tool, get last trace, and we can print it out similarly as before in a pandas data frame. And this is the expected result. The input is not necessary at step 1, and the latch gets the value 1 at step 1, and therefore it violates the property. I mean, the target is reached. Needless to say that this is Python, so instead of writing instructions like this, you can create a for loop. You can, for instance, compare the result with the engine result, which could be reachable, unreachable, or unknown, and you know, do the normal programming as you could do with a scripting language like Python. That would be the result. I will now show you how to interact with the REST API of Intrepid. So Intrepid also comes with the container, which can be activated with the following command. So it resides on Docker Hub, it's public, and when you run this line, it will first download the image, then run a container, and set up a server on this port, 8000. Make sure that you don't have anything else running on that port on your local network, otherwise it will conflict. Anyways, with this command I have created a service that is running on my local machine, and of course the same could be done for if you have a remote service, like installing multiple Docker container on AWS or a service of the like. But now I will show you briefly how to interact with the REST API using a popular program called Postman. Basically, Postman allows you to define some REST queries, and so I will be able to interact with the server. So first of all, I can use this API to create a context. So I have created a context name default, and I can go and create an input. I can specify the type and the context of reference, and I created an input, and I can also create another one. Okay. Now I can create an AND gate between the two, and I can try to ask BMC whether that target is reachable. So I create a BMC engine, which is given the name E0. I add the target that corresponds to the AND gate, which I have created before. I set the current depth to 0, and I can ask the engine to solve the query, and it is in fact reachable. Similarly, I can get the trace, which is called T0, and also retrieve the value, which is true and true for both. So as you've seen, you can effectively interact with Intrepid out of the box by means of the REST APIs, and that opens a number of possibilities, like installing the container on the cloud, orchestrate, and slice your problem and give it to multiple engines to solve. Thank you for your attention. More information can be found from the GitHub page. Thank you.